servlet or filter controller in Jakarta server pages. Now we are focusing on servlet filter. This is controller. Jakarta servlet, formerly Java servlet, is a Java software component that extends the capabilities of a server. Although servlets can respond to many types of requests, they most commonly implement web containers for hosting web applications on Java servers and thus qualify as a server-side servlet web API. Such web servlets are the Java counterpart to other dynamic web content technologies such as PHP and ASP.NET. A filter is an object that performs filtering tasks on either the request to a resource, a servlet or static content, or on the response from a resource or both. Here you can see life of a JSP file. Here the JSP container. Here the translation occurs at this point if JSP has been changed or is new. If not, translation is skipped. So this is translation passed, and if not, this is Jakarta servlet, formerly a Java servlet. A Jakarta servlet possesses or stores a Java class in Jakarta EE that conform to Jakarta Servlet API. A standard for implementing Java class that responds to requests. Servlet could in principle communicate over any client server protocol, but they are most often used with the HTTP. The servlet is often used as shorthand for HTTP servlet. Thus, a software developer may use a servlet to add the dynamic content to a web server. Using Java platform, the generated content is commonly HTML. But may be other data such as XML or more commonly JSON. Servlets can maintain state in a session. Servlet can maintain state in session variables across many server transactions by using HTTP cookies or URL mappings. Jakarta Servlet API has to some extent been superseded by two standard Java technologies for web services: the Jakarta RESTful Web Services JAX-RS 2.0, useful for AJAX, JSON, and REST services, and the Jakarta XML web services JAX-W is useful for SOAP web services. To deploy and run a servlet, a web container must be used. A web container, also known as a servlet container, is essentially the component of a web server that interacts with servlets. The web container is responsible for managing the lifecycle of servlets, mapping a URL to a particular servlet, and ensuring that the URL request has the correct access rights. The servlet API contained in the Java package hierarchy javax.servlet defines the expected interactions of the web container and a servlet. A servlet is an object that receives the request and generates the response based on the request. The basic servlet package defines Java objects to represent servlet request and responses, as well as objects to reflect the servlet's configuration parameters in the execution environment. The package javax.servlet.http defines HTTP specific subclasses of generic servlet elements, including session management objects and that track multiple requests and responses between web server and the client. Servlet may be packaged in a WAR file as a web application. Servlets can be generated automatically from Jakarta server pages, JSP by Jakarta server pages compiler. The difference between servlets and JSP is that servlets typically embed HTML inside Java code, while JSPs embed Java code in HTML. While the direct usage of servlets to generate HTML has become rare, the higher level of MVC web framework in Jakarta EE, JSF, still explicitly uses the servlet technology for the low-level request response handling via the Faces servlet. A somewhat older usage is to use servlets in conjunction with JSP in a pattern called Model 2, which is a flavor of Model View Controller. The current version of Servlet is 5.0 at this moment. Here you can see JSP containers. Here you can see the JS request is passed from client to JSP page.jsp, and there are the if the translation occurs at this point, if JSP has been changed or is new, then JSP page is connected to JSP translator here, for example Tomcat, and JSP translate is connected to JSP source code Java, and JSP translate is connected to Servlet source code Java. Servlet source code is connected to Java compiler embedded server. Java compiler is connected to Java server class .class, and Java JSP translator, and Servlet source code, and Java compiler and server class is inside translation base, and server class is connected to JRE. JRE is connected to text buffer in memory. JRE and text buffer is connected to execution pace, and text buffer is connected to client. Response is passed from text buffer to client. And here if not translation is skipped, here that if JSP has not been changed or not new, then translation is skipped, and then JSP page.jsp is connected to text execution pace here, and it's connected to text buffer here in memory, and text buffer is connected to client here. Response is passed from text buffer in memory to client. Now here you can see the illustration is detailed step-by-step description of each number in the image in MVC with Servlet and JSP. Servlet were very popular even JSP's first arrived, and because of easy to use and fast deployment model, they were used to do everything. MVC using JSP is possible, but scriptlets make your pages very hard to read, and when you start mixing JavaScript, CSS, HTML and Java all in one files, it's easy to get the 1000 lines, meaning that the output will normally be a long HTML file that will take a lot of time to load, render and execute JavaScript code, not to mention the readability problem. To avoid the separate Java code from and the separate Java code from HTML, normally Servlet is used. The Servlet do all the heavy lifting, load model data, process, modify it, and then save it back, and then add it to the request as described, request as attributes, and dispatch it to the JSP file that will use the expression language. And taglibs to generate HTML code that will be rendered on the client side. Some people even argue that that makes it easy enough for designers to generate HTML in those fancy design tools like Dreamweaver or Illustrator, but some people don't like the automatically generated HTML because the tools still aren't good enough, and designers and programmers, most of them don't like to be responsible for HTML, and they aren't paid to do that. Some people think that is a part of their job. Back to the MVC stuff. The following is the illustration that shows how request and response flow is handled. Handles then in a sample project. After the illustration is we are going to describe description of each number of in the image. One, the Tomcat receives the request and passes it to the base servlet. That is an abstract servlet class that all servlets should be extended to get the basic request response functionality. Step 2, the base servlet calls the execute method of the subclass. Step 3, the execute method is where the real action happens and all exceptions should not be handled will be and there is here is where the servlet access the data access layer. For data access layer handle all conversation with the database and passes only object back to the servlet. 5, after loading or updating the data subclass of base servlet, only need to return a string that says how the response should be handled. The dispatch method will handle the forwarding to JSP or a redirect instruction back to the browser. If an exception is thrown by the execute method, it will be handled and redirected to the error.jsp page. Here JSP's base servlet and servlet subclass, DAO and databases are in this picture inside the Tomcat web server. The request is connected to do get or do post, and do get and do post interacts with the base servlet, and then base do post in the, here then base servlet interacts with execute in here the servlet subclass, and execute interact with the data DAO, and DAO interacts with the database, and here the dispatch is connected to JSPs, or here the then dispatch and the dispatch is connected to response via error or redirect. Here you can see a servlet filter in a Java web application. A servlet filter is an object that can intercept HTTP request targeted at your web application. Servlet filter can intercept requests for both for servlet, JSPs, HTML files or other static contents, as illustrated in this diagram here. So here servlet filter and servlet, JSP and static file are inside the web app. HTTP request is connected to servlet filter. Servlet filter is connected to servlet, JSP and static file. Now we are considering working of a JSP filter. JSP filters are the Java classes that primarily are used for intercepting the request from any client or to manipulate the server response. Additional techniques like logging and auditing are used by the filters to provide functionality of data security by encrypting the data as well as providing the user authentication. To create and implement the filter interface, the older java.servlet class can be employed, or Jakarta.servlet class can be employed. Apart from JSP, servlet and other markup languages like HTML make use of filters. Moreover, we can also see the use of filters in images and videos as well. It is evident that in some conditions where it is required to degrade the performance of say videos, filters are being used to add some extra complexity, maybe because it is very fast and very much accessible by different user environment. The web.xml file, which is used to define filters, are being mapped to servlet and or JSP pages in order to use the filter functionalities. JSP containers are invoked when JSP codes are run, and at the same time an instance of filters that are deployed in the deployment descriptor file is created. Here the request is connected to filter and filter 1 and filter request is it is connected to filter 1 via request, and filter 1 is connected to filter 2, filter 2 is connected to filter 3, and filter 3 is connected to JSP, and JSP is connected to filter 3, and filter 3 is connected to filter 2, and filter 2 is connected to filter 1, and filter 1 provides response. Here you can see the filters are called by the application application server, both prior to and subsequent to the resource processing of a request. This figure illustrates the simplified view of a middle tier server, emphasizing the request and response flow, and showing where the filters fit in the picture. You can see that the filters are positioned in the processing pipeline between the application server and the client. Filters provide application level access in the request handling pipeline of a container. Before the advent of filter, there was no way for a web applications to participate in the processing being performed along with the request handling path. A web application could only supply and define the resource that were being served. If the application required to access the processing pipeline, you have to resort to non-portable server level extension interceptors, valves and like, which you will and other stuff. Due to their strategic position in the request processing pipeline, filters can easily handle the pre and post processing of request for resources such as HTML pages, JSP pages and Servlet. This specialized construction of filters will actually allow them to participate in the processing of a request or response throughout the processing path. You also have the option to chaining several filters together dynamically to process each incoming request. This allows the filter deployer to combine the action of 2 or more filters at deployment time. At runtime, the container uses filter mappings to determine the filters each request and response will pass through. Here you can see the incoming request is connected. Incoming request is passed to the filter 1, and filter 1 is connected to filter 2, and filter 2 is connected to process resource. Resource and filter 1 and filter 2 are inside the application server. You can see the processing pipeline, and process resource interacts with static HTML, Servlet and JSP page, and process resource is connected to filter 2, and filter 2 is connected to filter 1, and filter 1 is passing ongoing response. Here you can see filtering pipeline. Filters can act as filters can act on a request before it reaches to the resource, and on the response after the resource has been accessed. Filters enable a developer to tap into the pipeline request and response processing. A filter can do its work just before a resource is fetched or executed in the case of dynamic output, and immediately after the resource is fetched and executed. It's even possible to inject custom behavior while the request is being processed by the resource. More specifically, when you apply this notion to the HTTP based request and response that serviced by a middle tier servers, filters can be used to do following: inspect the request header and data before it reaches to the resource, inspect the response header and data after it has been sent by the resource, provide modified version of the request to the resource being processed by the container, access and modify the response from the resource before returning it, and stop request from reaching a resource altogether. You will examine you should note that the code implement in filters can have the same power, if not more, as the code implement in resources. In other words, servlets and JSP pages when it comes to the request processing. In some way, you can view the servlet engine and JSP engine simply as endpoint filters in this processing pipeline. Here you can see it's connected to the filter, and this filter is connected to this one, and here the filter has access to request before resource processing, and this filter is connected to this filter, and this filter is connected to resource processor, and resource processor is connected to this filter, and here the filter can supply wrapped version of request and response for custom behaviors, and this is connected to, and here the filter has some filter access to response after resource processing, and this filter is connected to this one, and then it's provide response. Here this is the filter pipeline. Now we are considering life cycle of a filter. Here the life cycle of a filter is similar to the life cycle of a servlet. The filter is created, then initialized, it processed requests, and it is destroyed when no longer needed. Just like servlet and JSP pages, container manages the lifecycle of a filter. Now here we are considering a filter. This figure illustrates the lifecycle of a filter by using block diagram to represent states that the filter can be in. As you can see, the filter lifecycle is almost identical to that of the servlet lifecycle. The 4 stages of the filter lifecycle: instantiation, initialization, filter execution, and destruction. Of the 4 stages, there are only 2 explicit states: initialization and initialization and filter execution. In the other 2 stages, the filter's instance does not exist. It is either being created or being destroyed. For each filter definition in the web application, as specified in the web.xml, the container will create an initialized the filter instance. Every filter must implement the Jakarta.servlet.filter interface. This interface defines 3 methods: init, do filter, and destroy. These 3 methods and constructor corresponds to 4 stages of the filter lifecycle. The construct is called during instantiation phase. The init method is called for initialization. Do filter method, which contains all the filter processing logic, handles the filter execution phase. Finally, destroy method is used in the destruction phase. That single filter instance, which is the initial parameters, will service all requests that correspond to its filter mapping specified within the deployment descriptor. The only exception to this occurs when the engine consists of multiple virtual machines, VMs, servicing requests. In this case, the container mechanism will create one instance for each VM, thereby allowing all participant VMs to service filtered requests equally. The container will call destroy when the web application is shut down. The initialization must occur before the first request is mapped through the filter instance. During the initialization, the container passes filter config object via the init method of the Jakarta.servlet.filter interface, javascript.servlet.filter interface. The filter config can be used by the filter to obtain initialization parameters of the filter, the textual name of the filter or filter context that application running under. Here the uninstantiated is connected to instantiated. Instantiated is connected to initialize via init, and initialize is connected to service request. Servicing request are connected to itself via do filter, and servicing request is connected to garbage collection and finalization via destroy. Now we are considering insertion of filters into the request flow. Here the incoming request is processed by 0 or more filters, and the response from the web server can be processed by the same set of filters. The filters and request dispatcher, to better understand how the request dispatcher interact with filters, we will process a series of figures depicting this request flow in a servlet container. Here we can consider action servlet 3.2 compliant containers. These containers support filters but don't support interact with the request dispatcher. This illustrates the filtering that will be performed. This figure is the conventional request flow. The incoming request is optionally passes through a mapped filter change before being sent to the final processing resource, typically a servlet or a JSP page. This is typical filtered request flow for all the servlet 2.3 compliant containers. Here the incoming request is passed to F1, and F1 is connected to F2, and F2 is connected to F3, and F3 is connected to web resource, and web resource is connected to F3, and F3 is connected to F2, and F2 is connected to F1. Then F1 is passing providing outgoing response. Here you can see when a resource in a server 2.3 container includes other resources, these resources do not get processed by filters. This figure reveals what happens when you use same filter mapping in two resources that are included by the main web resource via request dispatcher.include in a servlet or an include directive in JSP when using servlet 3.2.3 compliant containers. Here the incoming request is connected to is passed to F1, and F1 is connected to F2, and F2 is connected to F3, and F3 is connected to web resource, and web resource is connected to F3, and F3 is connected to F2, and F2 is connected to F1, and F1 is providing passing outgoing response, and here web resource is connected to interacts with included web resource A, and web resource is interacts with included web resource B. In other words, under servlet 2.3, here you can see in the servlet 2.3 containers, filters are not applied to these request for or response between original resource and the forward resource. Filters only applied between client and the request resource. In other words, under servlet 2.3 compliant container control, when the primary web resource uses request dispatcher to include the other processing resources, included the processing resource cannot be filtered. The same thing happens when the web resource uses request dispatcher to forward the request to other processing resource via the request dispatcher.forward method in the servlet, in a servlet, or JSP :forward in a tag in JSP. This figure illustrates this situation. Here you can see incoming connection is incoming request is passed to F1, and F1 is connected to F2, F2 is connected to F3, and F3 is connected to web resource. Here web resource is connected to forwarded web resource via forward, and forward web resource connected to a web resource. And here the F3 is connected to a web resource, and web resource is connected to F3, and F3 is connected to F2, and F2 is connected to F1, and the outgoing F1 is providing outgoing response. Here you can see when a resource in a servlet 2.4 or 2.5 container includes another resource, 0 or more filters can be applied as part of the inclusion action. A container such as Tomcat 5.5 allows filtering to occur in both the include and forward action of the request dispatcher. The dispatcher element of the filtering mapping allows you to specify that filtering is to be performed regular request dispatch, as well as when the request dispatch is called to include additional web resources. This figure illustrates the action of the filter mapping on the included web resources. Now filters can be applied in between the first processing filtering can be applied between the first processing resource and any included resources. For example, if the first JSP page include the output from the multiple JSP pages or servlet, the filters could be applied for each included resources. Here the incoming request is connected to F1, and F1 is connected to F2, and F2 is connected to F3, and F3 is connected to web resource. And here the is include F1 web resource interact with F1, and F1 via include, and F1 is connected to F2, and F2 is connected to F3, and F3 is connected to included web resource A, and included web resource is connected to F3, and F3 is connected to F2, and F2 is connected to F1, and F1 interacts with web resource. Here web resource is connected to F3, and F3 is connected to F2, and F2 is connected to F1, and F1 is providing outgoing response. Here the 0 or more filters can be applied to the request and response when a resource forward the request to another resource. In this case, the filter chain will operate in both standard request processing and the forward resource processing, as shown in this figure. This time the first web resource uses the request dispatcher forwarding capability. The resource that request is forwarded to is responsible for generating the actual output for the client. Here the filters are applied before the primary web resources and before the resource being forwarded to. The filter interaction with the dispatcher are controlled by the dispatcher sub-element of the filter dash mapping. Here the incoming request is connected to F1, and F1 is connected to F2, and F2 is connected to F3, and F3 is connected to web resource. Here the web resource interacts with F1 via forward. Here the web resource is connected to F1 via forward, and F1 is connected to F2, and F3 is connected to F3. F3 is connected to forward web request A, and forward web request A is connected to F3, and F3 is connected to F2, and F2 is connected to F1. And F1 interacts with web resource is connected to F3, and F3 is connected to F2, and F2 is connected to F1, and outgoing F1 is providing outgoing response. Now we are considering filter chaining, and all filters are chainable. For example, the design of the filter API provides an inherent chaining capability. The container works with each filter to filter and process the request as specified in the deployment descriptor. The compatibility with filter chaining is an integral requirement of every filter. Filter chaining is provided by the series of interaction between the container and the filter. This figure is a UML diagram of the interactions. Here is an explanation of what happens. 1. The container passes the filter mappings defined in the web.xml file of the application. 2. The request arrived accessing the resource in the application. 3. Container determines the filter chain that will be applied to the request. The container invokes doFilter method of the first filter of the chain passing the request and response holder in the filter chain object reference. The container loads the filter chain information into the filter chain object that is passed in. Filter chain perform is doFilter logic. 5. 6. Filter chain completes its filter logic and calls the doFilter method in the filter chain object reference, passing it to the request response. All filters are required to do this because all filters are intrinsically chainable. 7. The logic in the doFilter method of the filter chain object calls doFilter method of the next filter chain to be called. Steps from step 4 are repeated until the last filter in the filter chain has completed its work. The filter chain.doFilter call on the last filter call the last filter in. The note that the mechanism of chaining is inherently different from the most of other conventional filtering and server extension mechanisms such as Apache modules and Microsoft Internet Information Server and Internet Server API. Here you can see chain, container, filter and next filter in chain. The step 1 container passes the filter mapping. Step 2 the request arrives, and step 3 container determined which filter chain to apply to the request, and 4 calls doFilter process passing in the filter chain object. 5 perform doFilter logic of filter. 6 call the filter chain doFilter and filter chain.doFilter calls the doFilter of the next filter in the chain. Now we are considering terminology also here. A request from a client constitutes the downstream inbound trip of a request response cycle. The response from a web application constitutes the upstream outbound trip. Before you read any, this figure shows the request from a client as request flows through the set of filters and handled by the web resource. Notice this figure shows filter 3 being applied twice to request response cycle, or although this is not the common practice, it is technically possible. For example, you could have a adapter filter that modifies the request. Using initialization parameters, you could control how the filters modifies the request. Thus, one instance of the filter could modify one aspect of the request, and the second instance of the same filter could modify the different aspect of the request. The request originates from the client and goes through the chain of filters before reaching the final resource processor. In this figure, the first request travels from the client through the first filter, through the second filter, then so on. We will call this the downstream or inbound trip. The downstream trip always forward the final goal. The resource processor. After the resource processor is finished with the request, the response then will travel the upstream or outbound back through the filters and onward to the client. Upstream trips are always anyway away from resource processor and forward to the client. New to Servlet 2.4 is the ability to of filters and filters to participate in forward and include redirection request of the request dispatcher. This is very important advanced architecturally. Here you can see client is connected to filter 1 and filter 2, and then for the filter 1 is connected to filter 2, and filter is connected to filter 3, and filter 3 is connected to resource processor, and resource processor connected to filter 1 and filter 3, and filter is again connected to filter 3, and filter 3 is connected to filter 2, and filter 2 is connected to filter 1, and filter 1 is connected to client. Here you can see the from client, the downstream, and here an inbound or inbound, and here the to client, the upstream or outbound. Now we are considering a filter in the request processing pipeline. In the pipeline model, different processors can act upon the request as it travels through the system. There are many names given to the pipeline data processing model. It is often identified as enabling element of model view control, MVC, web application design, and sometimes it's referenced to as push model of application design in contrast with the more conventional push model. The idea is simple, but you have to think beyond the conventional web application wisdom to get bigger picture. Consider the illustration of the model shown here. The request enters to the system and is shuttled along a pipeline. As it traverses the pipeline, the sequence of processors has to access the content of the request. Each processor perform some task on the request, and then it either adjusts to some new attributes or modified the existing attribute as the request of the work. Then the request remain intact until it hits the final stage of the pipeline, which is especially processors called renderers. Examine all work being done to the request and produce the final response. Renders are always called view component in MVC paradigm because they alone are responsible for final presentation of the user. You can see why this is often called push model. The data attributes are fetched by the processors, pushed along the pipeline with the request, and the renders only at the final stage. The another common analogy for pipeline model is the conveyor belt or assembly line. Each processor mirrors the workers or robots along the belt or line. Some of the highly desirable properties of a pipeline model are as follows. The request stays intact as it traverses the pipeline, with the work being carried out only on the attached attributes, sometimes called decorators. Data management, business logic, and presentation logic can be cleanly separated into different processors and renderers. The processors can be designed to completely composable, that is changed in any order, or highly specialized to work only with the specific attribute created or modified by the other processes. Multiple renders can compose finally output such as data to XML or HTML via XLLT. The state of the request travel with the request through the pipeline. The processors and renderers don't keep track of the requested independent state at all. This makes it possible to duplicate or shuttle the request and its state before multiple POSIX servers if necessary. In general, designing request handling logic by using pipeline model provides the following. Processors and renderers that are readily reusable as components. Strong and clear separation between data management and business logic and presentation logic in an application. Applications that are more maintainable, applications that are more adaptable to changing business requirements, robust applications that will be scalable with container technology and hardware advances, web application whose performance is highly optimizable. The last point may not be immediately obvious, but any processes in the pipeline that don't depend on other outcomes can in principle be executed concurrently, perhaps on two physical processes, for instance, and any grouping of the process that has an outcome independent of others can execute concurrently. In the past, the limitation of content implementation have prevented the use of clean pipeline design model. Servlet 2.5 has features that bring a dream of creating pipeline applications closer to the reality. Here you can see the request flow, and this is the pipeline here. Here the request flow interacts with processes, and here the request interacts with processor renderer and is provide response out. As an example, we can consider this code segment. Here the next let's update the JSP page to work with Java Servlet. The idea is adding a web form and on submit the form will be processed by a servlet. At this code between the body tags of the page. This HTML code adds a form with the text field and a submit button to the page. The action attributes of the form specify the URL handles this form's submission. In this case, we specify the path which is relative to the application, and it points to the Java Servlet which we will create. As an example too, we can consider Jakarta.servlet, the module Jakarta.servlet here. As an example 3, we can consider package Jakarta.servlet. The Jakarta.servlet package contains a number of classes and interfaces that describe and define the contracts between a servlet class and the runtime environment provided for an instance of such a class by a confirming servlet container. For versions prior to 4.0.2, these classes and interfaces are described by the Java Servlet API specification. For version 4.0.2 and later, they are described by the Jakarta servlet specification. This package is in module Jakarta.servlet. As an example 4, we can consider this servlet. This example servlet prints how many times its service method was called. Here the class HTTP servlet provides an abstract class to be subclass to create an HTTP servlet suitable for website. A subclass of HTTP servlet must override at least one method, usually one of these: do get, if the servlet supports HTTP get request; do post for HTTP post request; do put for HTTP put request; on delete for HTTP delete request; init and destroy to manage resources that are held for the life of the servlet; get servlet info, which the servlet uses to provide information about itself. There's almost no reason to override service method. Service handles HTTP request by dispatching them to the handler methods for each HTTP request by request type. The do access methods, the do xxx methods listed previous here. Here the method void init servlet config called by the servlet container to indicate to a servlet that the servlet is being placed into service. The protected void service, HTTP servlet request and HTTP servlet response receives standard HTTP request from the public service method and dispatches them to the do xxx method defined in this class. Here you can see the destroy public void destroyed method called by the servlet container to indicate to a servlet that the servlet is being taken out of the service. As an example 5, we can consider interface servlet. Interface servlet defines method that all servlet must implement. A servlet is a small Java program that runs within a web server. Servlet receive and responds to requests from web clients, usually across HTTP, the hypertext transfer protocol. This interface is in package Jakarta.servlet. And here is the code example of a Java servlet which supposed to handle a logging request. It redirects the user to the home page if logging successful. Here the method in HTTP servlet request, the get the request dispatcher get request dispatcher string path returns request dispatcher object that acts as a wrapper for the resource located at the given path. A request dispatcher object can be used to forward a request to the resource or to include resource in response. The resource can be dynamic or static. As an example 7, we can consider interface servlet config. A servlet a servlet configuration object used by a servlet container to pass information to a servlet during initialization. This is in module jakarta.servlet and in package jakarta.servlet. We can, as an example 8, we can consider servlet mapping example here. This is in file web.xml. With regarding configuring servlets, you define servlet as part of the web application in several entries in J2EE standard web application deployment descriptor web.xml. The web.xml file is located in the web-inf directory of your web application. This one is basically, here we are talking about WebLogic server. The first entry, the web.xml file is located in web-inf directory of your web application. This is regarding WebLogic server. The first entry under the root servlet element in web.xml defines defines a name for the servlet and specify the compiled class that execute the servlet. Or instead of specifying servlet class, you can specify JSP also. You can specify JSP. The servlet element also contains definition for initialization attributes and security roles for the servlet. The second entry for in the web.xml under servlet mapping element defines the URL pattern that calls the servlet. here this do filter is belongs to filter chain method, filter chain here, and this is these are two different methods. So here as an example 10, create the following entry for the filter tag in the deployment descriptor file web.xml. Here this filter would apply to all JSP because we specified / asterisk in our configuration here. Here you can see we are now considering a servlet for the compiled JSP page. Here you can see the servlet code only depends on the JSP 3.1 and servlet 6.0 API as follows. As an alternative, the JSP page is compiled into an servlet with some implementation dependent name com.acme. Here underscore JSP underscore hello world underscore xxx underscore impl. The servlet code only depends on the JSP 3.1 and servlet 6.0 API as follows. Page context, create initial JSP writer out. Example, we can consider class servlet exception defines a general exception a servlet can throw when it encounters difficulty. This is in module Jakarta.servlet and package Jakarta.servlet.